Amy Hardberger and Dr. Scott Collins. I also should have done this much sooner, but we do have a celebrity in the audience. Director, Texas Water Development Board Director Ashley Morgan is here visiting and learning about West Texas, as well as her Chief of Staff, Kate. So it's great to see y'all in the audience. Thank you so much for being here. Also, quick question for you Lubbockites. Is Lubbock West Texas? I think this is a contested issue. I personally
We'll talk about it at the bar.
Yeah. Well, we'll save that for the reception.
Yeah. Is this on? Oh, yeah. Okay. All right, so Scott and I have been charged. I'm sorry, I'm very ADHD. There's no way I'm going to be able to sit while I do this. Welcome to the life of my students. Scott and I are charged with talking about beneficial reuse of produced water in a lightning fast period of time. So we will be around if you have follow-up questions after this. The lead up to this has been sensational, talking about the PACUS and things like that. So here's what we know. All right, I think everybody knows this. I'm going to fly through these first few, but I do want to make sure that we're all on the same page. You know, what is this water source that we're now talking about that historically we didn't want anything to do with? Isn't it interesting what time will do? You know, during the fracking process, producers are putting large amounts of water mixed with sand and a mix of chemicals down in order to free up this shale that previously would not have been able to be recoverable. Also included in the water that goes down, these formations have their own water. That all mixes and comes back up, and we call that produced water. Now, those people that work in this, you might be like, no, that's flow back. There's a difference. I'm talking about it all as produced water. It's much easier. We could do definitions for hours. How much water are we talking about? Well, in some places, a lot, right? And so in particular, in the Permian Basin, we see large amounts of water coming out of the production wells, and we have to do something with this once the product has been separated out. So that might lead you to the question of, where have we been putting this all along? Well, we've been doing deep well injection. And when I say deep well, I mean very deep, thousands of feet deep, into very deep formations. We have put the water, the mix, the slurry, all of the things down there, mostly because we didn't want to interact with it, the cost of treating it, there wasn't a driver to treat it, and it was, in fact, considered waste, so the goal was to dispose of it. So we have mostly deep well injection. There is some shallow injection, but that's what we've been doing historically. So there's an interesting culmination of events happening here that has forced a different conversation about the potential for reusing this water in other places. One of the biggest drivers is that the opportunity for deep well injection is closing. These formations are becoming full. We have increased seismicity from a lot of these injection. Towns don't like for their towns to shake, generally speaking. And when you're in a place where this is happening regularly, you know, the legislatures and policymakers got involved and said, you have to come up with another solution. So on one side of the equation is we have to find, oil and gas needs to find a place to put this produced water because the traditional path is no longer as available as it used to be. Sort of on the other side of the ledger are the things that we have been talking about all day. If you hadn't noticed, in this area of the world where a lot of the production happens, and particularly in the Permian, where you do have a lot of water that needs to be disposed of, and over in New Mexico, there's not a lot of water around, which has driven this conversation of, is there the potential to beneficially reuse, treat, and reuse this produced water? This is not I would never be able to put this together. I completely stole it from our colleague who's an engineer. I'm a lawyer, I don't do this stuff. So, why are we here together? Because we are both involved in the Texas Produced Water Consortium, which was created, really spearheaded by Senator Perry, and funded through the legislature. And we are a study center, a multidisciplinary study center located at Texas Tech, which is what the Lubbock question was. And one of the very exciting things about participating in this, it is truly multidisciplinary, especially over the last couple of years. I'm part of the leadership team. Texas Tech has water centers across the campus, so I'm the director of the policy center. We have a water center in the agriculture department. We have one in engineering. All of us are working together to look at the different aspects of this. So we have ecology and hydrology, land application, that's our ag area. We've got water quality and tox folks, of course, policy and law, energy water nexus, and then all of our engineers talking about treatment technologies. So that's ultimately what we are doing, and what we're funded to do is to provide this information and reports back to the legislature about, can you clean this water? What are the concerns if we put it here? What are the concerns if we put it there? So what are we going to reuse it for? What can we reuse it for? Well, everything seems to be on the table. You can sort of start with a range of land applications. So one of the land applications that comes up a lot is rangeland restoration. Maybe you have an area where you want to enhance the ecosystem through, you want to plant grass, maybe it's been overgrazed, a million different things. Using it on agriculture, whether that be food crop or non-food crop, is around. Livestock, groundwater recharge has come up. That raises some concerns for folks because if it isn't clean, that's going to be dicey. And one of the things that my colleague will be talking about, which is the direction that a lot of things have gone in recently, is this idea of surface water discharge. One of the drivers, I think, for surface water discharge is we have a permitting plan for that. It essentially goes through the Clean Water Act. Whereas a lot of these rangeland restoration pieces or land application, there are questions about what policies would be there. Are there protections in place for human health and the environment? So, and then I will say on this, of course, for each one of these, there are a lot of different potential vectors or things that might come into contact with it. So when we're thinking about the science of it, we have to think all the way through that chain, which makes it pretty complicated. Just a very, very high-level overview of what the current policy situation is. If you're really interested in being bored and listening how other environmental laws might be involved, come talk to me. I've written about it. It's great for insomnia. But essentially, one of the biggest issues when we started talking about beneficial reuse of produced water, it took us a long time to figure out, is this a Railroad Commission thing or is this a TCEQ thing? So the legislature has helped us out there more recently. And essentially, if it's water discharge, it's going to be TCEQ because it is a Clean Water Act permit. But one of the bigger issues is, what about land apply? And so we do have some clarity on that, in that the TCEQ is now in charge of land apply and is obligated to create some standards, some policy standards for that. How much can you put on, what does it have to be, et cetera. There are, of course, federal law overlaps. Again, this is very detailed. Usually this type of waste would qualify for RCRA, but there's an exemption because it's oil and gas waste. So then there's a question of, does it lose its waste exemption if it's actually going to be for beneficial reuse, if it has quality now? There's a lot of questions about who owns it. So we've had some litigation on that. If people have questions in the question and answer time, I'm happy to discuss that. And then, of course, there are some regulations if you're putting it on food crops, what type of water can be on it. One of the things that's very challenging about this is that these laws were passed at a time that nobody would have thought about putting this on food crops. So if you look at, for example, food crop regulation, it's really focused on things like E. coli and heavy metals. So it's looking at biohazards and any kind of heavy metals. So some of that might overlap with fracking, but there's also many, many other chemicals that might be in produced water that were not considered at the time that those laws were being passed. So that can just create some challenges. I will say, before I hand it over, There are several permit applications that are pending in front of the TCEQ that operators and midstream operators have already requested. So I think one of the biggest challenges that I've felt in doing this work is, as the Produced Water Consortium, we're trying to well, not me, this is the royal we. The scientists, I started my life as a scientist, so I'm just going to claim it, but they're trying to do this work. It takes a long time to understand what is the longitudinal impact of these chemicals on small creatures. What is the impact on soil and whether that soil can maintain crops? How much uptake do plants have and then we eat them? And we have this parallel process where TCEQ is already considering permitting. And so I don't really understand exactly how those two things are going to work together in the end, so don't ask me that question. I don't have a good answer for you. But there's been some really interesting science going on about surface water discharge, particularly into the Pecos, so I'll hand it over to my colleague. Oh, clicker, sorry. I'm not listening.
Oh, hello everyone. My name is Scott Collins. I'm a freshwater ecologist at Texas Tech. I'm an associate professor in the Department of Natural Resources Management, and I love rivers. So I'm here today, just like others, to advocate for healthy, clean rivers. I'm really excited. This is my first time attending this conference, and I assure you it won't be the last. I was really excited to join the consortium because as someone who studies rivers, I've had the good fortune of researching mountain streams, prairie rivers, the Great Lakes tributaries, all of that over the course of my career. And to find myself in not West Texas, but down in the prairie at Texas Tech, I've had the good fortune of being able to kind of apply my focus to the study of the Pecos River. And it's got a pretty rough reputation. And as someone who wants to protect the animals, the aquatic organisms that are in these aquatic systems, that's really my skill set. One of the unfortunate things in the world right now is that globally, our rivers are generally shrinking, as in there's just less and less water flowing through them. There's reduced flow, and there's also just tend to be getting a little saltier. Like this is this global freshwater salinization process. It's not exclusive to our part of the world, but our part of the world is really emblematic of it because the degree of salinity that we see within the Pecos rivers is really, really high. It makes it a really challenging environment if you're an invertebrate or a fish. So my focus when I joined the consortium was kind of to be like, in a way, kind of the Lorax. Like, I'm an ecologist, so I'm going to speak for the invertebrates and the fish, the algae, all these animals that historically called the Pecos River home, but over the last century have really experienced a tough time because of a myriad of factors within the watershed. This is a photograph I took last fall near Grand Falls. That's not snow. Hopefully you can appreciate in October in that part of the world. We're not getting any snowfall. That's all the nice little lovely salt crust that has formed near the side of the Pecos River. This is just right underneath the highway bridge. And when it rains, that's going to dilute, go into solution, and get flushed into the Pecos and get washed downriver. Here's another photo of some little salt crusts that are just forming on the base of some vegetation here. It really does make a particularly challenging environment for a lot of our aquatic critters to make a living and just to make it through. It's probably no shock to anyone as well. Over the past 85 years, the total quantities of water that have been flowing through the Pecos River have declined. This is a hydrograph near Girvan, Texas, from about 1939 to, that's supposed to be 2025, not 2925. This is about 31,487 individual days of discharge recordings, so it's a really good timeline. And we can see this general trajectory. The y-axis here is in a log scale. So we're getting less and less and less water. So those of you who were around in 1940 could probably appreciate there was just a lot more water flowing through the river itself. As we see these reductions in discharge through the Pecos River, we're also seeing increases in total dissolved solids, which is really driving that salt regime, that salinity regime that's out there. I got two different plots here. This one's near Grand Falls. We see between about 2011 and 2025 here on the right-hand side. We see pretty high values in and around Grand Falls. Some of these daily readings are approaching marine seawater, which is particularly concerning. I'm a freshwater ecologist. I'm not a marine biologist, but I might have to venture into that part of science here. So, you take what you're dealt with. But further down, if we go down to Pandale, we can see that our salinity concentrations are considerably lower. There's that dilution effect as those springs kick in, and Independence Creek definitely helps to improve it. It's a lot more hospitable down there. It's a lot easier if you're a macroinvertebrate or a fish to simply survive. In part because this salty water, how you cure meat, right? You salt it and it draws the moisture out, right? Well, imagine trying to live and breathe when this really salty water is drawing moisture from your very cells, from your gills. So it's a tough time for a lot of these organisms. And so that ultimately leads me to this potential, anyway, rewilding of the Pecos River. For the past, 40, 50 years, there have been a lot of ecologists and a lot of scientists through our state agencies, through our academic institutions that have studied the Pecos River. A majority of these questions have been focused on just kind of like, oh, darn, this river is not doing too well. It's not particularly healthy. And what are the negative and detrimental effects on the animals that call the Pecos River home? But this idea that there's going to be this desalinated, polished, produced water discharged into the Pecos River leads us to some research questions that we really haven't been able to ask. Because the general thought is if the water is clean and it meets those permitting guidelines and it's suitable for discharge into the river channel, it's probably going to be less salty than what's currently in the river. So there's going to be some presumable dilution effect. We should expect to see some reductions within the salinity across the Pecos River, increased discharge, so you have your normal base flow as the water moves through. As some of our speakers mentioned earlier, it's dry in many places right now. So some of these contributions are also going to hopefully facilitate long-term year-round flows within the river. That's all dependent on a lot of other hydrologic processes, which we have a team at Texas Tech that we're working on answering those questions. But the idea moving forward is, can we see the productivity, can we see the food web of the Pecos River improve? And that's really something that we're excited about because, as our previous speakers had mentioned, both the Rio Grande and the Pecos are probably at all-time lows. It's the minimal amount of flows that are coming through. The salts are as salty as it's probably ever been. Most of the native biodiversity is probably is really at an all-time low. So these kind of additions really stand to improve the health and condition of the ecosystem. But that's why I'm here. That's why our team of aquatic ecologists, we have a team of graduate students and postdocs. We're looking out there for y'all to collaborate and to help us understand how the river may change. But we're data driven. We don't want to make any claims until we actually have the data in hand to do so. But we really do want to track and see as these additions of water make their way into the Pecos, as these permits are allocated and these sums of water are contributed to the system, will we see kind of demonstrable increases in the suitability of the habitat? And how suitable will it be for the many different invertebrates and fish and amphibians and reptiles that called the Pecos River home? So we're kind of just working on this overarching hypothesis that if you dilute the water and have more flow through the river channel itself, you're going to improve the suitability of the habitat, and we expect to see this kind of rewilding of a really, really large landscape level effect. And so we're really, really excited about that and those possibilities. One of the challenges, though, is that if you build it, will they come? It's easy to degrade something. It's much more challenging to restore and rebuild a degraded ecosystem because in a lot of cases we need source populations to recolonize, and we don't know where those recolonists of species might be in order to kind of foster that increase in biodiversity. But we're hopeful and we're positive. And I think if you talk to any of my colleagues as aquatic ecologists and you explain those two basic conditions, more water and less salty, that's usually a path towards recovery. And we're suited through this monitoring program along the Pecos River to track those changes through time. And we really kind of figure out how quickly will it take for their recovery to happen. We're also taking a multi-trophic level approach. We don't want to just look at the animals that are in the river, but all of the other wildlife that are dependent on the river itself. And so we're literally tracking algae and insects through the fish, the emergence of aquatic insects. So adult dragonflies spend a good portion of their life in the river. So if we get more dragonflies or midges, mayflies, you're also feeding aerial insectivores like birds and bats. If we can help fuel the productivity of the river, we can also fuel the health and productivity of the riparian corridors. And we're going to take this much more holistic kind of approach to track those problems. So with that, I think we have about 5 minutes to handle any questions. So.
Nailed it. That was a hard timeline to hit.
I have two questions. I'm not from here, so where does the salinity in the Pecos River come from? The salinity that's there already. And question number two, where are you going to put the salt that you take out of the produced water? Thank you.
You want to talk about original salinity, and then I'll talk about this?
Yeah, so with respect to your first question, that's probably, if there is a geologist in the room, I apologize for my terror. I always default to, hey, I'm a fish guy when I get tougher questions like this. We typically, oh, whoa.
I am too, actually. I just don't do it anymore.
Oh, I'm getting quizzed here.
Yeah, I'm going to think of new questions.
Yeah. So we typically have a saltier landscape to begin with. Our subsurface geology is saltier. There are groundwater brine springs that also contribute salts, which contributes naturally to the Pecos River. So historically, it was even before rapid development across West Texas and the Trans-Pecos, it would have historically been a saltier river than others. In addition to that, how we're changing the surface of the landscape within the watersheds, we're exposing soils and sediments, and also when rainfall comes in, those exposed soils and sediments, those salts get flushed into the river channel. And so it's a really, as I understand it, a multifaceted kind of driver of saltiness within the Pecos.
Yeah, so I think it's all those factors plus low flow. So it's just crystallizing out instead of getting diluted. As to your second question, so yes, I'm not an engineer, but the treatment process that's being, developed and tested by engineers at different, facilities that want to treat this, there will be a waste stream for sure. There are way more than salts that are getting pulled out of this. So some of that may still be like a deep well injection, but considerably less than the water that we're putting in now, because it's actually the quantity of water that's loading the system that's creating the seismic activity. Just as a side note, there's other conversations about, are there other waste streams that would have profitability that we can separate out of that and sell to other folks. But just like with regular desal, there's no magic bullet to this, right? This isn't some magic water source that's going to solve our problems. It has, it's all about risk mitigation. It's all about what your priorities are.
I'm a landowner on the lower Pecos where that rural freshwater was. And so have you thought about, by increasing the upper Pecos, bringing salinity into the lower Pecos? Right now, our environmental flows are intact. It's from a groundwater source. And so I can't imagine you having enough produced water to drastically change salinity in the upper, but you certainly could increase flow which could bring the salinity contamination into our spring-fed stretch of the river?
Yes, that's a great question. So, in addition to myself, we have some hydrologists that are associated with this project, where we will begin, where we will be addressing those kinds of like challenging questions. With respect to the volumes of water that are going to enter the Pecos, and as Amy mentioned, we're in many ways learning as we go as well in terms of how many permits are out there and how this how this water is going to be allocated spatially, where is it going to be discharged, but also in what volumes and quantities. These permits have caps on the total quantities. Is that correct, Amy? So there's total quantities that they can discharge into the river. So we're facing difficult challenges of trying to understand this both spatial issue, where's the water coming in from, and also a temporal one where once you get the permit, then you have to build the infrastructure, I think, in order to actually discharge that. And so there's a temporal component to this, and then it's also kind of stair-step as more permits come online. It's not going to be a wall of water, but at the volumes of water that they're talking about, I mean, I think we're going to see definite increases in CFS, and we're trying to figure out what those volumes are, what the dilution factor is from those contributions, and what that means for Orla and Girvan and Langtree, and to the point as well, Amistad and Falcone and the Gulf, because water flows downhill, and eventually if the volumes are sufficient, there's going to be a lot of water that needs to be accounted for as we think about this issue. So.
Yeah, I'll just add to that and say, the devil's always in the details. I think one of the challenges that I think about as, a former geologist, I guess once a geologist, anyways, is, if we have permits that are up to a certain amount of water, and let's say, it's probably not going to stop at 4, but let's say we have 4, are they all going to sort of turn it on at the same time and the same day and be, and what is the consistency of that? Because I think that's really where we get to the answer to your question, because these volumes are high enough that if everybody is, full out putting that in there, I don't think downstream we have salinity issues. You may have some geomorphology issues. You're going to change the look of the river in some places. We're talking about getting a geomorphologist to be modeling increased siltation. Where is that going to go? You're going to have kind of a scouring. And so once we start to see these draft permits, and my recommendation is keep your eye out for the draft permit, because it will be really interesting to see, in addition to the constituent levels, can't have more of this thing, what are the conditions on which you can have releases? Because that's really, I think, where the unintended consequences can come from, ironically, because most people are worried about what's in there, but I think when you start thinking about this discharge, a whole bunch of things can happen on a natural river.
I have a question. Has anybody modeled, or are you modeling now, the consistency of the supply? So as the production changes, what's the future here?
We're doing that. So we have Sungyu Park is our hydrologist. He's currently building this big hydrologic SWOT model right now, and those are the exact kind of questions, and we're trying to entertain different types of scenarios for additions. Typically, when I think of the hydrology of a river, it's how much precipitation did you get, how much snowpack was up in the mountains, and that affects the natural flow regime of a river. Now we're going to have the Pecos River's hydrology is very tied to the economic, international, and national drivers of oil demand in West Texas. So does it peak when it's cold or when we're driving a lot? And what mismatches are potentially going to happen with the hydrology is one just basic question if you're watching water flow past your property. But all the animals that called their a dynamic river their home, like what does that mean for those that call it a home as well? So yeah, there's a lot of really weird questions, fascinating, big, wicked kind of questions, but they're weird questions too.
And I know we're out of time, but I would just say on that realm, it's not just how does it affect stream water ecology, it's also the economic factor of how big of a solution is this water? It's not just that it's a lot of water, it's how long is it going to keep flowing to that? If you start getting, farmers dependent on this and, irrigation systems or, critters, this is highly dynamic. This isn't going to go on forever, and it is very much affected by the price of oil. So those are all the types of things that we're trying to figure out.